On this channel, there's for some reason, and I really don't get why, a ridiculous focus on my Germanness. People are commenting what kind of crazy you are. The German kind. Bros like German soding. Nah, not really. German accent to the top. Wow, really a real German. Physiognomics 10 out of 10. No idea why. Are you a furry? Are you a furry? Also, are you German? What the hell? And someone even commented, I don't know why this comment doesn't show up here. I like your channel, I like your videos, but I don't like that you're German for some reason. Well, thanks. Okay. So in this video today, I want to emphasize my Germanness by trying to enter a system by pure force. I don't want to apply intelligence I don't want to imply clever thought, intelligent and reasoning to crack a simple password and pin protected file. I just want to apply pure force. And to do that, we're going to code a small little Bruteforcer. For that, I found on crackmes.1 a file. Let's search it and let's search for pin. Linux, Unix, and pin. And there's this crackme that's called authorized by pin. Small, easy crackme. Really, it's not hard, but it's nice to walk you through this. So let's download it and see. Normally, a crackme is a file that is intended to be cracked by somehow reverse engineering the file. So we can call that file with a pin, for example, 6666, and then we get a response. This is not right. Now, the idiomatic way of reverse engineering would be to now create, for example, an object dump of that file and inspect the hexadecimal data, the binary data inside that file. The issue is, this is way too hard, this requires thinking, and I want to enter this by just blasting a rocket of information at it to destroy the pin lock. All right, it's really super simple. By the way, in one of the last episodes, we used the strings utility to print all the strings that are embedded in a file. And this could be useful in this case as well. But it's not. And the reason is, we can see a couple of strings here. For example, that this is not right string. And the usage string, which we already have seen printed to the console. And then your first guess might be that this pin-looking thing here is the actual pin. This would be a clever solution to this crackme. So we can call it with that pin 8446, but it says this is not right. Why is this not right? Probably because it's obfuscated. So we have to, in order to determine what the correct pin is, we have to somehow decompile the code or understand assembly. I don't know what we have to do. I don't want to deal with it. We can also do an object dump, disassemble, authorize. If you are an expert at assembly reading, then you can read this and just immediately see what the pin is. I can't. I just want to enter that damn program. I want to get the success message the fastest possible way. What is the fastest possible way? The fastest possible way is, since we know that this crackme contains a pin and a pin is just a number, let's just brute force the number. I mean, how hard can it be? How many digits should it be? Even if it's 9 digits, it takes a computer basically no time to count up to that number. So we can just write a small little program instead of doing all that reverse engineering that brute forces the pin. And maybe we could even do a one-liner, honestly. a one-liner of pure force, but I think having a small script looks better. All right, so what do? We start with an echo command. For example, we echo some pin to the console. That's how it works. Echo. There, it prints out the pin to the console. Now, instead of echoing it to the console, we can echo it into the authorize function, but it doesn't understand it because it expects the pin not piped to standard input, but it expects it as a positional argument as a positional argument. So the 1, 2, 3, 4 pin must be supplied as authorize 1, 2, 3, 4. And only then we get a printout. How can we now convert this standard input to a positional argument? We can do that by calling exargs. And exargs takes what is written into standard input and positions it after this executable. And as you can see now, the 1, 2, 3, 4 is accepted as a positional argument, and it's printed to the console that this is not right. All right. If we look up the manual or the help of exargs, then we can probably get some useful option here that allows us to prompt before running commands. So let's try that. If we do exargs dash interactive or just -p, whatever you prefer, I prefer to write out stuff, then it even asks us whether we want to execute authorize 1, 2, 3, 4, and then we can hit enter. I don't know why it didn't print anything to the console. All right, but that is how it's work. That is how it's working. Maybe it's just a help to. I thought maybe this is just a help, a guide, an aid to tell us what is being executed, but we have to append a Y to indicate yes, we want to execute that. And if we do and hit enter, then we get a printout. This is not right. All right, so that's how we provide arguments in Bash via standard input using this exargs utility. Now, what we can do is we can automate creating multiple such arguments using Bash. For example, using a loop. We can just create a loop starting at 0 and going up to, let's say, 10 for the first example, and increment the integers, and then we can do echo integer and done. And as you can see, we print stuff to the console. Now we have printed 10 integers to the console. Now, instead of echoing them to the console, we can just execute them as arguments to the executable. So instead of echoing this and printing it to the console, we can just do echo pipe exargs authorize. And actually, I wanted to write a script, but now I'm already in the middle of writing a one-liner. I just love Bash one-liners. They are somehow magic to me. They are just fun to write. They feel like a superpower. So exargs authorize, and then let's see what's happening. And at printed, this is not right for the first 10 inputs. So we just checked the first 10 inputs, just like that. Automatically, we didn't do anything. Now we could also, now we have to do some if-else checking to check when this message is not printed, but instead we get a success message. But because if we execute strings authorize, then you can see that it contains also a success message. This is not right, but correct pin in entered. So we have to watch out when the correct pin was entered. So instead of printing all the messages to the console, we can just write a bash script. And let's do that now. I think it's time. Let's create a bash script, pinforce.sh, vim pinforce.sh, and in this bash script, we just create the same loop. I starts at 0, I smaller than And let's just count up to 999,999. 999,999, and then increment I in between, and then do something and done. That's the syntax for the for loop. And now we just echo the pins into X args, authorize, and try out pins. And then this prints out something to the console. We can just try that here. Let's execute the script. It doesn't work like this because we have to prefix it with the // to indicate that it's in the current directory, pinforce. But this still won't work because we're lacking permissions, as you can see now. So we have to first give it execute permissions, and then we can do pinforce sh. And this is not working, or this is just printing this is not right a million times to the console, which is obviously not what we want. We want to check for the success message, so we can just store the result here from this execution in a variable results. And if the value of the result, that's important, don't forget the $, guys. If the value of the result is equal to, and let's check what the success message is. I can just grab for doesn't work. Correct pin entered. If the value is correct pin entered, then we do something. What do? Then we print to the console that we have found the correct pin. Echo found pin. And then we just supply the pin, which is the current integer I. All right. And that should find the pin. Of course, we also interrupt the execution after the pin was found. And just like that, we have I think, working Bash script. Now I just want to make this a bit better and print out usage instructions. So if the number of arguments, I think it was this variable, is equal to 0? No. What do we do? No, we have to do not equal. Wait, what was it in Bash? Not equal. I think it was this. And let's expect 3 arguments, and those arguments are the executable is the first argument, then the expected success message, or maybe we should even check for the expected failure message. That is the second argument. And I think that's it. So the number of positional arguments should be, I have to look that up again. So Bash number of arguments. It's $#. Okay, so that seems to be fine. And if it's not equal to 3 or 2, let's try 2. I don't know if it takes the program name as the first argument. I think it does. But in that case, we echo to the console usage. And the first argument that is required is the executable file name. And the second is the expected failure message when the pin entered is wrong. Just like this. And then we can replace in these executions here the actual executable. And the expected failure message should be checked here if the result is not the expected failure message, then we have a success. If the result printed from the execution with the given pin, then we have a success. So let's save that, and I think we should be good to go. I'm just not sure about this if statement here, honestly. Syntax error, yeah, the not equal looks somehow wrong to me. No, this is the wrong browser. This one. Bash, number of arguments, not equals. It's just NE. Okay. And that should be it. So let's go down here. This is our bash script. And in the bottom terminal, let's try to execute it using just the name of the script, which was pinforce, no arguments provided. This prints the usage, and of course we have to exit with a failure code in case we enter no positional arguments. But I'm confused why it says found pin 0. That's obviously wrong. We have to of course dereference the expected failure message. We have to say if the result is not the value of the expected failure message. Because if we don't provide a $sign here, and that's the same reason because of which I said that you have to remember it here before the result earlier. Always prefix the $sign when you actually want to retrieve the values of those variables. Because otherwise, without a $sign, Bash will interpret that as the literal string, as this string, which is obviously wrong. So Bash only understands that you want to get the value of a variable if you prefix the $sign. All right, and that might be it. Yeah. All right, so that's the complete script. Let's try it, and we get a usage indicator here. So now let's follow it. The name of the executable is... and there's one more detail. If we just provide the name of the executable here, which is authorize, and then the expected failure message, which is, wait, let me check it here, authorize and then some pin, then the failure message is this is not right. So let's provide it here. Oops, this is not right, copy it. And here it's very important to put it in quotes, otherwise Bash will interpret this as separate arguments, obviously. And we have, one more detail. We also have to make sure that the results and the expected failure message are put in braces, because otherwise Bash won't be able to handle the spacing in the variables well. Maybe even in quotes. Quotes and curly braces are ensuring that we handle spaces well. Yeah, because the failure message that it contains spaces, so we have to make sure that it's really all put into a single string, delimited by quotes. Or not delimited by quotes, but encapsulated, wrapped in quotes. So let's try to execute that, and it won't work because it doesn't find this authorized file. And I still don't get why it says it finds the pin. But we will check that later. The issue is that the authorize function, the authorize method, is not found because we have to give it the full way to execute it, the full syntax to execute it, which is this. So this is the function execution. If we just provide this, then the Bash script will try to call xargs authorize, just like this, without the /, which will attempt to look up this executable on the path variable, which won't be found. So we either have to do this, or if we know it's a local file, we can also do / like this. Maybe this is even more convenient for our use case. Yeah, so let's provide just the file name here. And let's try to execute it and see if we can find a pin. I don't know. And we found a pin. That's awesome. And it's as easy as that. It's pure force. No intelligence applied. Zero intelligence applied. It's just writing the script. So let's try the pin which we just found in this terminal below my webcam. Or maybe, no, it's better in the other one. Maybe let's try the execution in the terminal below the webcam again, just so we have it stored here. And also prefix that with time, so we track how long it takes to crack this pin. Let's see. And as you can see, we found the pin 3991. It took 11.4 seconds. It's not super fast for such a short pin. I mean, it's counting up to 3,991. That's nothing for a computer, but still it took 11 seconds. It's probably because of that string comparison here, which is not the fastest thing in Bash. There's probably a better way to do it, even in Bash, but I'm just using plain Bash here. I'm not using some magic executable, some magic utility, which nobody knows of. This is a plain Bash way to do it. All right, so we found the pin, and let's just try to authorize with that pin, or let's try to authorize with a wrong pin first, just to confirm that we get a "this is not right" message. And now to follow up, let's enter the correct pin 3991. And as you can see, we get the success message, correct pin entered, decoded string, JCTF, maybe J, I don't know what that stands for, but that is probably a capture the flag abbreviation. And then this string says encoding is fun. And we wouldn't have found this password simply by looking up the strings in the executable. Just as a reminder here, the string stored inside the executable is this one, which is probably the pin, but it's obfuscated somehow. And we would have to somehow reverse engineer it. And by the way, this is the obfuscated success message. So we print out correct pin entered, and then print out something, decoded string, passed here as the formatted string. This is the input, and this is probably what results in this right here. All right, so just a small wrap up. We coded a simple brute forcing application in pure Bash. It's super fast. Well, fast enough for just deciding or preferring to just brute forcing the pin rather than having to reverse engineer it completely. And it's fast. We don't have to think so much. And what did I even want to say? It's successful. It's a success. All right. It even works with pins that are obfuscated in memory. Awesome. So whenever you know that the pin to an executable is somehow retrieved offline and you don't know it, and it's reasonably brute forceable, so that means the executable doesn't do any online checks or it doesn't lock you out of the system if you try and fail too many times. If you can just enter a pin and retry again and again, infinitely, then just create a small brute forcer. I mean, at that speed, it will even be fast enough for, let's say, 9-digit pins. Yeah. All right. I hope you enjoyed this episode. Some basic brute forcing here. And of course, if you have any feedback, anything that I should look at in the next couple episodes, then put it in the comments and also provide your feedback in the comments. I'm learning a lot of stuff from you guys. So yeah, let's all together continue our day positively. If it's morning or evening in your where you live, whether it's morning or evening where you live. Have a great day or a great night, and see you in the next video. Stick around. Bye bye.